butterfly in the sky. I can go twice as high. Take a look, it's in a book.
All right, we're going to take a look at scientific notation today. Scientific notation is something that probably a lot of you have experience with from like science class. So we're going to look at it as far as math goes, make sure that we understand all the steps of how to put a number in scientific notation and then how to do operations with it. So first, understanding what a scientific notation is. It's a way to write either really, really big or really, really small numbers in a way that makes them more concise, so short and sweet, okay, like me. Step one is we're going to move the decimal point until it is to the right of the first non-zero digit, okay? That non-zero digit, we need A, okay? Let's rewind for a second. Scientific notation is typically in the form of A times 10 to the nth. A has to be in between, it can be 1, it cannot be 10. It's got to be a single digit, okay? 1, 2, 3, 4, 5, 6, 7, 8, or 9, okay? And it's always an integer, all right? So it's not going to be an integer, but just that first, the A value, it might be 9.6. What I'm saying is that number has to be 1, 2, 3, 4, 5, 6, 7, 8, or 9. Okay, it's got to be, it can be 1, it can't be 10. Single digits. All right. We're going to note the number of places that we move it, and the number of places we move it is going to be the n. If we move the decimal point to the left to make a really big number small, then n is positive. If we move it to the right to make a really small number big, or bigger, then it's going to be negative. And then we remove unnecessary zeros. So it looks like this. If we're going to express each of these in scientific notation, we would move the decimal point until it gets right there. So then it's 2.01, and we moved it 8 times, so it's 2.01 times 10 to the 8th power, okay, 10 to the 8th power, so that's 201 million. Here, a really small number, we move it right, so it becomes 5.1 times 10 to the negative 5, all right? Big numbers get a positive exponent, little numbers get a negative exponent. Go ahead and pause the video right here and see if you can get me the scientific notation for 1A and 1B. Pause the video now. All right, you have unpaused. Hopefully for this one, you got 6.87 times 10 to the 10th power. And hopefully over here for 1B, you got 7.25 times 10 to the negative 5. Okay? Hopefully that was easy. If you need help with those, make sure you make note of it, and I'll go over more specifically in class. We can also write scientific notation. We can go the other direction. I can give you a number in scientific notation, and you can tell me what that number is. If this is positive, it's going to be a really, really big number. If this is negative, it's going to be a really, really small number, and that's telling you how many times we move the decimal place. That's all we're doing. Okay. Go ahead and pause the video here. See if you can do 2A and 2B. All right. 2A. Hopefully you got 3,201,000. Okay. And for 2B, hopefully you got 4 zeros, 2, 3, 4, 903. All right? Now, products and quotients in scientific notation, the same rules of exponents apply. It's why we do this in this unit. You might be thinking, well, why are we doing this when we're doing like polynomials and stuff like that? And the answer to that is, in this unit, we're working with exponents, and the exponent rules that we just spent all last class going over apply to scientific notation. So if I'm going to multiply 3.5 times 7, I do that and I get 24.5. This is 24.5 times 10 to the second, because negative 3 plus 5 is 2. Now, the key is, and this is a big deal, so like super like star, asterisk, whatever, this number is not between 1 and 10. So this is not scientific notation. I think the book does a really good job of change 24.5 so that it is scientific notation. So that 24.5 is 2.45 times 10 to the first power. But you can check that in your calculator. 2.45 times 10 is 24.5. So then we have 2.45 times 10 to the first times 10 to the second. Well, we add the 1 and the 2 and we get our 3. Okay? Easy enough, and we want them in scientific notation and in standard form. Get me some answers to 3A and 3B. Go ahead and pause the video here and get answers to 3A and 3B. All right, you've unpaused. Hopefully for 3A, you got 5.655 times 10 to the negative 2, okay, which is 0.05655. Okay. And in 3b, hopefully you got 6.084 times 10 to the negative 7th, which is also known as 0.000000, 6 zeros, and then 6084. All right? Let's take a look at what's next. So if we just did multiplication, obviously now we're going to do division. Same thing, same rules. 3.066 divided by 7.3 is 0.42. This is not between 1 and 10. So we change 0.42 to 4.2 times 10 to the negative 1. And then 8 divided by 10 to the 8th divided by 10 to the 3rd is just 8 minus 3, so that's 5. So then we have negative 1 and 5. They add to 4, so 42,000. Okay? Go ahead and try 4A and 4B and get some answers there. All right. 4A is 1.21 times 10 to the negative 5th, or 0.00000121. And 4B is 9 times 10 to the 6th. 9 times 10 to the 6th, also known as 9 million. Okay? Scientific notation is really useful in real-world problems because it lets us, again, talk about really big numbers in a really simplified way. So the problem here is that the United States, a CD reaches gold status when it's over 500,000 copies. Platinum is over 1 million. So we express the number of those numbers in scientific notation. And then we can talk about how many copies of a CD has sold if a CD has gone platinum 13 times. So it would be 13 times 1 times 10 to the 6th, which becomes 13 times 10 to the 6th, but 13 is not between 1 and 10, so we change that, so it's 1.3 times 10 to the 7th. Okay, pretty simple stuff. Here, 5A, B, and C, it's a satellite radio company. It's their earnings in 1 year. So first, we write it out in standard form, then you write it in scientific, and then if the following year they get 2.5 times that amount, write your answer in scientific and standard. Okay, go ahead and do that now. All right, for 1A, hopefully you got 125,400,000. For part B, hopefully you got 1.254 times 10 to the 8th. And for part C, hopefully you got 3.135 times 10 to the 8th, or 313,500,000. And that's it. Okay? Some practice problems here for you to try. And we'll look at these in class. So these, sorry, let me scroll down. So you can pause it right here, and then I'm going to move it so you can see 19. So there's 19. So you're going to try these. Make sure that you have this skill down a little bit so we can have a good starting point to talk about it in class. Sorry about that. All right, so there you go. There's those, and there's 19. That's it, guys. See you next time. Bye.